Hello there, welcome to the June 2018 applied paper. Here we're looking at question 2. Tessa owns a small clothes shop in a seaside town. She records the weekly sales figures, measured in W pounds, and the average weekly temperature, T degrees Celsius, for 8 weeks during the summer. The product moment correlation coefficient for this data is minus 0.915. Stating your hypothesis clearly and using a 5% significance level, test whether or not the correlation between sales figures and average weekly temperature is negative. Okay, so the way we start all hypothesis tests is with that hypothesis. So H0 is when you're doing a product moments correlation coefficient hypothesis test, it's that rho is equal to 0. Now what rho is, it's the product moments correlation coefficient for the whole population of data rather than just this sample of 8 weeks that Tessa has taken during the summer. So this would be the correlation between the two variables here for all of the weeks during the summer. And the alternate hypothesis is that there is negative correlation, so rho is less than 0. And the test significance level, is 5%, is 0.05. Okay, so what we now need to do is go to the formula booklet and go to the product moments correlation coefficient section. We are testing at the 5% significance level, and our sample size here is 8 because Tessa tested for 8 weeks during the summer. So we're going to go across and read the table here, and down and read the table here. So the key variable that we're looking for here is 0.6215. Now actually, this product moments correlation coefficient table is both positive for positive correlation and also exactly negative, so you just put a negative symbol in front of all these numbers for negative correlation. So the formula booklet table, formula booklet results, is minus 0.6215. Now what this is saying here is this is the amount of correlation, this is the amount that the product moments correlation coefficient should at least be in the negative part of the range of values for us to consider it to have negative correlation. So therefore, as minus 0.915, which is very good correlation, very good negative correlation, is less than 0.62 minus 0.6215, so there is enough evidence to reject the null hypothesis and that there is negative correlation between weekly earnings and temperature. So there we are, that's our little conclusion after this hypothesis test. So it's just comparing on the formula booklet table and then making a decision as to whether is there correlation or is there not correlation. If this value that Tessa found here was maybe minus 0.5, then we'd have to say no, there's not enough evidence for correlation, so therefore we'll assume there's no correlation. But in this case, we can assume there is negative correlation. We have enough evidence to support that. Okay, let's move on to part B, C, D, and E. Let's just grab the formula booklet. So, suggest a possible reason for this correlation. Well, let's just have a look at what the answers say. So, as temperature increases, people are more likely to spend time outside and hence do less shopping. So, as the temperature goes up, people do less shopping. And when it's windy and rainy, people want to go into the shops to shelter and will also potentially buy stuff along the way. Tessa suggests that a linear regression model can be used to model this data, states giving a reason whether or not the correlation coefficient is consistent with Tessa's suggestion. Yes, well, given that R is either close to -1 or potentially close to 1 as well, it is very close to negative correlation, in which case the data is quite linear, so therefore it is consistent with Tessa's suggestion, or it supports Tessa's suggestion that she should use a linear regression model. Part D is state giving a reason which variable you would use as your explanatory variable. Well, the explanatory variable is the one that will change, and then the dependent variable is the one that we'll see the result or the effect on. So T is the explanatory variable. We're seeing as temperature changes, what is the effect that it has on weekly sales figures So T is your explanatory variable because T is the one that changes, and we see the effect on the wages. Part E is Tesla calculated the linear regression equation as W equals 10,755 minus 171t. Given interpretation of the gradient of this regression equation, well, what it's saying here is that as we increase t by 1, the weekly earnings, the weekly wages, weekly sales figures, sorry, is going to decrease by £171. So as the temperature increases by 1 degree, the weekly sales figure decreases by £171. And there we are, that's our answer for question 2, worth 7 marks in total there. Let's now move on to question 3.